to the organizers for the opportunity to share information about PANGEA, which is a scoping study for a possible NASA terrestrial ecology field campaign. I really wish I could have been there with you all in person. I am the PI. My name is Elsa Ordway. I'm faculty at University of California, Los Angeles, and I'm the PI of PANGEA, which is the Pantropical Investigation of Biogeochemistry and Ecological Adaptation. And over the course of this talk, I'll share with you what a terrestrial ecology field campaign is run by NASA and what we're proposing to be carried out in the tropics. So I want to start with first acknowledging that there's many, many people who are involved in PANGEA and have supported it from the proposal stage. Many of these folks are on the leadership team you see here. And there's many folks who are involved in further developing the ideas. We've been spending the past year developing the concept for this proposed campaign. And the folks you see on the screen here have been critical in leading those efforts to develop the potential contributions and the design of a campaign in the tropics. So what is a NASA terrestrial ecology field campaign? This is directly from a solicitation that came out last year. These campaigns are really focused on answering big science questions in a particular biome or region. They're meant to enable ultimately more effective interpretation and analysis of satellite measurements. Within, but also defined for the community. And they're also really meant to support and training opportunities to support the next generation of scientists and technicians as well in leading this effort. I'll talk about an example that many of you are likely familiar with as well that demonstrates that sensitivity has a sample included a legacy of data. And that's something that NASA is really encouraging in this process. So the campaign I was referencing that has left an incredible legacy is albeit large scale biosphere experience in California. For those who aren't familiar with that was a campaign run by the in the year 2000. And NASA was involved with part of it called LBA and it was the NASA Terrestrial Ecology Hydrology program that was involved in LBA. This was a really critical campaign that was gathered in a multi-different folks responses to things like deforestation and just general function by coordinating the parts through one campaign. And it really did move the needle on the understanding of Amazon system. It also is really important because of the legacy it left in terms of experience. We've trained over 1,000 masters and PhD students, many of them were from Brazil. And this was also the cohort of folks continuing on to lead a lot of research and applications and activities in the Amazon through academic and entrepreneurial and government positions. And I think likely many of the folks in the room came out of LBA, and we're still seeing a lot of incredible work that has kind of built upon earlier work that started during LBA. LBA very much has continued beyond the campaign. So although the campaign officially ended in the early 2000s, LBA is very much alive and well and now moving into phase 3 of their efforts. The above campaign is another example, the Arctic Boreal Vulnerability Experiment. That is a campaign that's currently wrapping up, and it's been focused on Western Canada and US, primarily in Alaska. And the reason I included this diagram here is because this scaling focus is really a framework that all of these terrestrial ecology field campaigns emphasize, which is improving our ability to satellite data by conducting the surveys to ultimately scale reef level, sea level, ground level measurements by coordinating that with tower data, drone data, aircraft data collection to better interpret and utilize satellite data sets, as well as improving. So now that above is ending, the solicitation came up last year to determine what the next possible, especially as our field campaign will be, that NASA supports. So two scoping proposals were funded. PANGEA is one, ARID, which is focused on dryland systems, is the other, that's led by Dr. Reed and Andrew Feldman. Both teams have spent the better part of this year working with the community to determine what the scientific priorities and opportunities are, build relationships, define shared goals, evaluate what is feasible within the scope of a campaign like this, and determine what the geographic scope should be. Both PANGEA and ARID will deliver 60 days to NASA headquarters at the end of this year by September 5th. And NASA will make a determination likely by early next year, probably mid-spring, around March of 2025, to determine which campaign will move forward. And at that point, there will be a team that's coordinating the So the reason we're focusing on the tropics, which I don't think I have to spend too much time on given the expertise in this room, is because these systems are critically important. Despite covering less than 10% of the ice-free land surface, they maintain over 2/3 of all diversity on the planet. They're home to over 3 billion people who directly and indirectly depend on them. And they constitute major water and heat pumps, which is a large reason they contribute to local, regional, and global climate regulation. They're also, as you all are very well aware, important for the global carbon cycle, accounting for upwards of 30% of terrestrial net primary productivity and an incredible amount of carbon storage. These systems are also changing rapidly. They're entering a no analog state, which will be compositionally different than anything found today. One example of the kinds of changes is through increased temperatures that will soon be hotter in most tropical systems than they've experienced in their evolutionary history. This is going to lead to rain shifts, adaptation, acclimation, local extinction. Many questions, though, remain as to the direct impacts and the implications of those impacts. But ultimately, we do know that tropical forest function is likely going to be greatly diminished by the end of the century, resulting in these critical climate and carbon cycle feedbacks. However, in spite of the global importance of these systems, there's still a huge amount of basic knowledge that we lack about these systems. One example of that is the role that they play in the future carbon flux, land carbon flux. This is a figure showing 11 different Earth system models that disagree in terms of the capacity of the land carbon flux to serve as a sink or a source by the end of the century. And other work has really highlighted that a huge amount of that uncertainty and model variability is in tropical latitudes. On the x-axis, you're seeing latitude, and there's about 3 times greater output variability from models in tropical latitudes. So within PANGEA, we're really focused on working with the modeling community as well to improve data model integration, particularly remote sensing data model integration, and trying to better understand what processes need to be improved in the models. For example, the update between the CMIP5 and CMIP6 model community really worked to improve things like nitrogen limitation and its impact on the carbon cycle in these models. And that did have quite an impact, but we still need to do a lot of work to ensure that we're getting the right answers for the right reasons. And there's a lot of questions about additional processes that likely need further constraining in these models. We're also already seeing examples of responses that differ across the tropics to extreme events. You're seeing here a figure from a paper that was led by Junji Liu using orbiting carbon observatory data that showed that in response to the 2015 El Nino event, all tropical continents, which typically serve as a carbon sink, actually flipped to being sources of CO2 emissions to the atmosphere, but for different reasons. So in the Americas, it was drier land surface that led to less plant growth that resulted in more emissions. In Africa, it was increased temperatures and more respiration. And in Asia, it was a hotter, drier land surface that led to more fire, which was ultimately what led to more CO2 emissions. And even with these similar pathways in terms of a potentially fragile carbon sink that becomes a source in response to extreme events, the differences in terms of mechanisms underpinning these responses are critical to understand if we're going to think about effective solutions and management. So PANGEA is really focused on broadly understanding how vulnerable or resilient ecosystems in society are to environmental change and carbon cycle perturbations in the tropics, recognizing that given the diversity of these systems, the heterogeneity, the distinct long-term human interactions, there's huge differences in responses to change that are already emerging across the tropics, and those need to be better understood. And a coordinated campaign like PANGEA has the capacity to fill in massive data gaps that exist that are really needed to fill in before we can ultimately leverage the kinds of large scale monitoring capabilities of things like satellite remote sensing. And there's a huge component that I think is very similar with and aligned with the objectives you all are focused on, which is data fusion. Ultimately, we're focused on several different science themes, and our working groups, which are shown here in the middle of these circles, are focused on defining where the knowledge gaps are that a campaign like PANGEA could contribute to, as well as the monitoring capabilities and application improvements that PANGEA could support. So we're thinking about everything from both CO2 and methane fluxes, as well as the role that biodiversity plays in those changing fluxes and the importance in terms of differences in responses. We're thinking about variability in terms of decadal trends, as well as extreme events, and the role of disturbances in these feedbacks, particularly things like fire, as well as drought, changing storm severity and frequency, and of course, deforestation and degradation. And in terms of applications, we feel that there's a real opportunity for PANGEA to improve monitoring capabilities and engage in solutions-oriented activities in the tropics with respect to everything from sustainable agriculture and deforestation-free supply chain mapping, biodiversity conservation, of course, thinking about carbon monitoring, and thinking about also improving our ability to make decisions related to restoration. Disaster alerts and response has come up through many workshops as a priority for a lot of folks who we work with, and that is very much central in thinking about the applications that could emerge from PANGEA. And we've also been working with a lot of communities to ensure that there's a component of PANGEA that's thinking about non-remote sensing data sets and more traditional forms of knowledge and information, and how can we actually more effectively integrate things like indigenous, traditional, and local ecological knowledge with the kinds of advanced capabilities we are able to leverage from satellite data sets, for example. And given the moment we're in, there's a huge opportunity to leverage a new wealth of satellite data that offers understanding of these systems from greater dimensionality. So we can go from understanding kind of the variation of these systems as being varying in greenness, which we know saturates fairly quickly in the tropics, to actually understanding the component parts of these systems. You're seeing here information from hyperspectral data, airborne hyperspectral data, that actually parses out variation in a tropical forest in Malaysian Borneo according to its different functional types along these ridgelines, hillslips, and valleys. And the kinds of current and forthcoming satellite data sets are going to be really instrumental in improving our capabilities for monitoring things like carbon and fire. But again, we're emphasizing that there's still quite a lot of data gaps that need to be constrained to fully and effectively leverage these data sets. PANGEA is really thinking about data fusion across a lot of different types of sensors, focusing on spaceborne LiDAR, forthcoming radar from NISAR and biomass, hyperspectral data sets, things like SWOT, which allows us to understand and monitor changes in surface water dynamics. And increasingly, we're at a point where we can understand, or at least start to partition fluxes, carbon fluxes. And so the goal of PANGEA is to ultimately leverage these data sets across the tropics for satellite remote sensing and modeling capabilities. And in terms of identifying where coordinated data collection will be for the scaling from ground measurements to drone and aircraft data, we're still working hard to gather information from the community about where existing data collection is happening and where PANGEA could reinforce, support, coordinate, and fill in where gaps exist. Recognizing that there's already many opportunities that are ongoing in the topics, we are working hard to coordinate as opposed to trying to reinvent the wheel or start from scratch. We recognize that there's a value in, again, coordinating and reinforcing what's already going on and identifying specifically where a campaign like PANGEA could fill in gaps that just are not currently being met by these other activities. To do this, we are spending a lot of effort to engage many different types of communities to co-produce and ultimately define what goes into this white paper that we submit to NASA headquarters. We've had workshops across the tropics, including in Manaus in Brazil earlier this year, as well as in Central Africa, Peru, in Thailand, in Washington, D.C. And we're working hard to ensure that a lot of voices are incorporated into this campaign, recognizing that ultimately this campaign will be for folks from and within the tropics, and for the next generation of scientists who will be able to most effectively, I think, kind of utilize the outcomes of a campaign like this. So to summarize, the three pillars of PANGEA are to advance scientific understanding of the heterogeneous land use and climate change dynamics in the tropics. A second focus is capacity building, really training the next generation of scientists from the tropics to be able to lead these scientific efforts. And third, to focus on improving monitoring capabilities, particularly thinking about carbon monitoring, biodiversity monitoring, and agriculture monitoring in the tropics using satellite remote sensing. With that in mind, I am very interested in hearing your questions and feedback. Again, I apologize for not being able to be there in person with you all, but I would very much encourage feedback and questions. The QR code here will take you to our website. My email is also on the bottom. You can contact me directly. And I look forward to hearing from you, and I hope you all have a fruitful workshop.